Okay, so we are back for part 2, and in this section we are going to determine the coordinates of our 60-degree angles. Um, so what I'm going to do is I'm going to start at the origin. I'm going to travel along the unit, that radian that follows 60 degrees. I'm going to drop down to the x-axis, create myself a right angle with the x-axis, and then I've created that triangle. So just like we did with the 30-degree angle, now we're going to do a similar process with our 60-degree angle. So now I'm traveling 60 degrees from the x-axis. So I have 60 degrees down in the bottom left corner, 90 degrees where it's intersected with the x-axis, and then my 30-degree value is going to be up in the top corner or top vertex. So just like we did with our last example, the unit circle has that every single radius has a unit value of 1. So we're going to go back to our 30, 60, 90 ratios of 30 degrees is across from x, 60 degrees is across from x multiplied by the square root of 3, and 90 degrees is across from 2x. So if I know that the length of my hypotenuse across from my 90 degrees is 2x, but I know the length of the hypotenuse for the unit circle is 1, when I set those equal to each other and solve, I can determine that my x value is 1/2. Okay, again, this is still the value that I have across from my 30-degree angle, but in this case, my 30-degree angle is in a different spot in the triangle. So the x coordinate, or the x distance that I travel from the origin over to that right angle, has a distance of 1/2. And then we will use that to help us solve for the length of the side opposite of 60 degrees, which would be my y coordinate, that vertical distance from the x-axis up to the top of that radius. So if it's x multiplied by the square root of 3 to get the distance of my across from 60 degrees, I'll have 1/2 multiplied by the square root of 3, which again works out to be square root of 3 over 2. So our 60-degree angle has coordinates of 1/2 for the x distance and square root of 3 over 2 for the y distance. So very similar to those that we did for our 30-degree angles, the x and y coordinates flip-flop places. Okay, so now what we're going to do is we're going to look at every angle that is 60 degrees from the x-axis. So I'm at 60 and then 120, 240, and 300. Those are my angles and my radians that are going to have the exact same coordinates. We're just going to change the value of the ordered pairs based upon their quadrant. So in quadrant 2, we're still going to have 1/2 and square root 3 over 2 is our values, but because we are in quadrant 2, the x value has to be negative. So we'll have negative 1/2, comma, square root 3 over 2 for the ordered pairs of 120 degrees. At 240 degrees, so at 4 pi over 3, again, same coordinates, 1/2 square root 3 over 2. But when we are in quadrant 3, we have to go to the left and down to get there, so both the x and the y coordinates are negative. So it's negative 1/2, comma, negative root 3 over 2. And last but not least, at 300 degrees at 11 pi over 6, or excuse me, at 5 pi over 3, wrong one, sorry guys, we are going to have 1/2, comma, root 3 over 2. But in this case, when we are in quadrant 4, our y value is negative, so our ordered pairs should be 1/2, comma, negative root 3 over 2. So you'll notice all of our 30s, 30 degrees or pi over 6 away from the unit circle are root 3 over 2, 1/2. all of the 60-degree angles, then flip-flop and go the other way. Square root of 3 over, or 1/2, comma, square root of 3 over 2. And again, change your sign based upon the quadrant that you are in. Okay, next we are going to build the unit circle, but we're going to break it into 8 equal sections, 8 equal angles. So if we take 360 and divide that through by 8, we will get a value of 45 degrees. So we're going to list all of our angles. We're at 0, and then 45 degrees, 90, 135 degrees, 180, 225 degrees, 270, 315 degrees, and last but not least, 0 degrees and 360 back end at the same place. We'll again take each of these and convert them into radians. So I'm going to take 45 degrees and multiply that by pi over 180. Hopefully you recognize that both of those, the 45 and the 180, are divisible by 9 or by 5, either of those, whichever you choose to do. I'm going to divide through by 9, so that would give me 5 pi over 20, which I can reduce again to be pi over 4. So that means we've cut the top half of the circle into force and the bottom half into force. So I've got 0 radians at 0 degrees, or pi over 4 at 45 degrees, 2 pi over 4, which is pi over 2 for 90, 3 pi over 4 for 135 degrees, 4 pi over 4, or pi, for 180 degrees, 5 pi over 4 for 225 degrees, 6 pi over 4, or 3 pi over 2 for 270 degrees, and then 7 pi over 4 for 315 degrees, and 8 pi over 4, or 2 pi, all the way back around. We are next going to draw our triangle like we've done in all the others. So following the 45-degree radius that's drawn, I'm going to drop down to the x-axis, create a right triangle. I'll pull that out to the side. And I really like my 45, 45, 90 triangles. They are the easiest to remember. So our radius, our unit of measure, is 1. And this formula that we have is x square root 2. So if I know that the hypotenuse has a length of 1, and I would use that little ratio of x square root 2, I can solve for x by dividing both sides of the equation by the square root of 2. We then do need to rationalize. So 1 divided by square root 2 gets multiplied by square root of 2 over square root of 2, which simplifies just to be square root of 2 over 2. So each of the sides of a 45, 45, 90 triangle have a distance both in the x and the y direction as square root of 2 over 2. So that means my coordinates for every single 45-degree angle are going to be square root 2 over 2, comma, square root 2 over 2. You will change their signs only when you go into your other quadrants. So at 135 degrees, my x is negative, so it's negative root 2 over 2, comma, positive root 2 over 2. At 225 degrees, both are negative because I'm in quadrant 3, so negative root 2 over 2, negative root 2 over 2. And last but not least, at 315 degrees, my coordinates are going to be square root of 2 over 2, comma, negative root 2 over 2 for the y value. And remember, each of our quadrantal angles, they are 1, 0, 4, 0, and 360 degrees, 0, 1 at 90 degrees, negative 1, 0 at 180, and 0, negative 1 at 270. That is it. We have completed the entire unit circle. We'll come back in a third video to put it all together in one, and then to talk about some of the patterns and similarities that we see as we go around the entire unit circle.